Reloading.
Yeah, it's done. Okay, so in 3.1, we have learned about the position. So when the questions ask about positions, remember three of this main thing. You need to identify the period, okay? You need to identify the group as well as the block. Okay, so in this case, when we want to find the period, you have learned about to look from the highest value of n. Okay, the highest value will give you the period. So if let's say the n equals to 4, then it's come from period 4. Or if n equals to 3, the highest value, then it's come from period 3. And then from group is slightly difficult for some of you because you may find finding the number of valence electron a little bit difficult. Okay, but anyhow, in order to find your group, where is it located according to the vertical column, you need to find out the number of valence electron. Or from here, you can also look from your valence electronic configuration. Okay, electronic configurations. So how many valence electron are they? Then it belongs to that group. So you need to understand that we have group 1, group 2. Okay, group 3 until group 12 is your transitions element. Okay, and then group 13 until group 18. So this one, you need to be familiarized with yourself, like how to identify the number of valence electron. So for example, if the electronic configurations give you 2 valence electron, okay, so it comes from group 2. If the valence electron come from valence number of valence electron have 4 valence electron, then you have to think, because 4 valence electron, it can be from group 4 or it may come from group 14. Okay, then you have to use your knowledge to identify the block. The main blocks over here divide into SPDF block. So it depends where is your last electron located. Now, if your last located inside the P subshell, okay, then it will be from P block. If your last electron in D subshell, then it will be from D block. So there is some problem from your question 4. Okay, last exercises. So madam will discuss again with you for the exercise question number 4 on Sunday. Okay, so this is what we have completed in our last lesson, and then you can rewatch back the recording to figure out how to determine the position. And then we have touched a little bit, just a little bit of chapter 3.2. So talk about the Z, okay, or the Z effective, our ZEF. Okay, so in this case, 3 of this is a new term, maybe it's a new term for you. Okay, and then it's a new concept that it will link to your following subtopics. So if you have a symbol Z, it means there is a nuclear charge, or simple words is your proton number. Okay, so Z is quite familiar like, what is your proton number, then it will be your nuclear charge. Okay, but more important is your Z effective. Okay, effective nuclear charge. Actually, how many charge apply to your outermost electron? Okay, so madam give an example over here. You have 2 diagrams. So I'm choosing oxygen with a proton number or the nuclear charge of 8, and then a fluorine with a proton number of 9. So here is the electronic configurations I have here. 1s2, 2s2, 2p4 for our oxygen, and then 1s2, 2s2, 2p5 for the fluorine. So over here, you can see for oxygen, my valence electron, 2s, 2p altogether, we have 6 valence electron. Okay, so inside this diagram, okay, quite familiar, you can see in the inner shell, we have our core electron or inner electron, 1s2. So this is your first energy level, we have 2 electron. Okay, this is something similar like you learned in your secondary school, whereby you learn about 2.6. But now you are going into a deeper layer. You are looking into subshell and also orbital. So we are not longer using the 2.6, but the concept is still the same. Okay, 2 is from n equals to 1, your first level. And then this 6 is come from your level 2, but it's split into 2s and 2p. So altogether, you still have 6 valence electron. Nothing different, it's the same. Just you looking into a deeper version. Okay, so if you're looking at this diagram, we have 2 electrons in the first layer, okay, and then 6 electrons on the outer layer, which is also your valence electron. So in order to find out your Z effective, okay, effective nuclear charge, we need to use this formula. So this formula, you just take it as an information. Normally, they won't ask you to find, but you need to understand what is the difference between the Z and also Z effective. So if let's say I'm using this formula to find the Z effective for oxygen, okay, I have to use the proton number 8 minus the sigma. The sigma over here means your inner electron. Okay, so remember inner shell, we have the inner electron. Outer shell, we have our valence electron. So we want to see this is our core or the inner. So we minus whatever electron we have inside the inner shell. And in this case, we have 2 electrons in the first shell, in the inner shell. And then your Z effective now become positive 6. This positive 6 means that your power or the forces of attraction from the nucleus apply to your valence electron, okay, or the outer electron. So I have a power of positive 6. Okay, if comparing to your fluorine, 1s2, 2s2, 2p5, over here, this is your core electron, okay, which the electron inside the inner shell. And then the 2s and 2p holding all together 7 valence electron is considered at the outer shell because now you only have 2 layers. Okay, so if you're looking at this diagram, my nucleus in center, okay, and then the first layer 2 electron, 1s2, and then the outer shell contain your valence electron. So altogether, I have 7 electrons. So if I apply the formula to figure out my Z, okay, then I will see this Z is my proton number with a 9 electron, okay, 9 proton number, and then minus the inner electron represented by this sigma, but still the same. I still have 2 inner electron inside the inner shell. So in this case, for my fluorine, okay, I have my Z effective equal to positive 7. So that means the nucleus apply the forces of positive 7 towards my valence electron or my outer electron. Do you get, madam? Means what I means for the Z.
Yes, madam.
Okay, yeah, I hope everyone is clear because later on you will use a lot of this term Z effective and then the shielding effect and so on. Okay, I show you one more example by using chlorine, which is one element below your fluorine. So for chlorine, we have 17 proton number. So if you write out the electronic configuration, it will show like this: 1s2, 2s2, 2p6, 3s2 is 3s2, 3p5. So you can recognize that 3s2, 3p5 is the valence electron. Since fluorine, chlorine in the same group, so the number of valence electron will be the same. But now what is different over here is the core electron. Okay, we have 1s2, 2s2, 2p6 all together give you 10 inner electron. Okay, inner electron can be more than one shell or two shell, depends. But the outer shell, you only got one shell. Inner shell can more than one. So in order to figure out, or madam put in the electron first, our valence electron over here in the outer shell over here, we have 7. Okay, so to find your effective nuclear charge, we're using the proton number 17 minus your inner electron. And in this case, how many inner electrons do we have?
10.
10, yes. We have 10 inner electrons. So that means if you can see over here, in the same group, actually, the effective nuclear charge are the same. Okay, so we have to look at where is it from, which group, which period. Okay, to do our comparison and looking at the trend. Is it increasing order or decreasing order? So for this concept, we are talking about the ZEF, okay, effective nuclear charge. And the next important terminology or the name is our shielding effect or screening effect. So madam was still using fluorine and chlorine as example to talk about the shielding and screening. Okay, so the video, if you're looking back at the video that madam shared last lesson, also kind of have some idea using magnet and the nails. Shielding effect is how many layer of the plastic bag or the paper bag wrapping your magnet. The more the wrapping, okay, it will decrease the attractions of the magnet towards the nails. Dia punya daya tarikan kurang sikit kalau dia punya shielding banyak. Okay, so dekat sini ada satu definition. You can see over here. The shielding effect, or sometimes called screening effect, is caused by the inner electron, okay, to reduce the nucleus attractions towards your outermost electron. Outermost electrons over here means your valence electron as well. So if you're looking at two of this example, we're looking at the fluorine and the chlorine. So the shielding effect is actually the inner shell. Dekat sini kalau madam nak tengok the forces of nuclear attractions towards the outer electrons over here. So the inner shell n equal to 1 is like a protection to reduce your nucleus attractions towards your valence electron. Okay, but when you look at the fluorine, okay, now I want to see what is the forces of attractions between the nucleus and the, I'm changing one color. Okay, so if you're looking over here, if I want to see the forces of attractions between the nucleus and my outer electron, yes, there is attraction, but it's blocked or is protected by the inner shell. So inner shell sekarang sudah jadi dua layer. Layer is much more bigger than the fluorine. Okay, so we can say that the forces of attraction reduces or decreases because you have more screening effect in this case. Okay, so in terms of screening effect, we can say that if I got more energy level, that means my shielding effect or screening effect will be higher. Therefore, the nucleus attractions will decreases. So everything is linked one by one by looking at the structure itself and the effect itself. So is anyone having questions about the screening or the shielding effect in this case? Ada soalan ke?
So basically speaking, one shell is like representing a shield, isn't it?
Yes, representing a shield. Shield,
So the
madam tak
more the
tahu
shield,
dekat
the lesser the effect, isn't it?
lesser the energy level, lesser the effect, yes. So how do you call the shield dalam BM kita panggil apa
Perisai.
What is it?
Perisai.
Yang lain faham kan? Madam tak berapa faham. Okay, it's just a protection, like actually to protect between the nucleus and the outer electron. Okay. So we want to see what is this terminology we want to use to explain in another concept. And let's see our next slide. Oh, before the next slide, I don't want to discuss about question number 4. Okay, so for your question number 4, some of you having some mistake and madam want to correct you at this time. Okay, so if you're looking at question number 4, proton of element D and E having the proton number 16 and 13 respectively. So that means D have a proton number 16, E has the proton number 30. Okay, so electronic configuration, most of you no problem. For E, 4s before 3D. So you got 4s2, 3D, 10. But until part B, some of you are making mistake for the element E. Okay, D no problem because we can see over here we have the valence electron 3s2, 3p4. So 6 electron, no problem. Everyone got it very well done. Okay, but for element E, when you see 4s2, 3d, 10, okay, the last electron is inside D subshell. You haven't entered P subshell yet. Belum masuk 4P lagi, awak jangan pindah masuk 3D. Kalau awak pindah masuk awak tukar position ini, sebenarnya tak ada masalah. Okay. Tapi awak akan ingat last electron dekat S subshell. Dan salah dah. Dia punya block dah salah. Dia punya group automatic awak akan jadi salah. Okay. So, madam punya suggestion, bukan salah kalau awak susun. Tapi, dia akan, it will make you confused. Okay. So, if let's say the electron it's just nice to enter 3D. 3D sudah penuh. Tapi dia belum masuk 4P lagi. Awak jangan terbalikkan susunan dulu. Okay. So, what is Madam is trying to tell you over here is 4s2 3d10 is your valence electron. Okay. So, in this case, valence electron for element E will be 12 instead of some of you writing 2. So those who are writing 2, please make sure you do your correction and correct your concept, yeah? Okay, so if you know already the valence electron of element E is 12 electron, therefore, last electron in D subshell will give you block D. Highest value, period 4, and then because it has 12 valence electron, therefore, it is in group 12. Now, group 12 is inside your transition element. Dia bukan dua valence electron sahaja. Okay, group 12 ada 12 electron, valence electron. Okay, and then the last question over here, slightly confusing because it's testing for your English. It asks to write the electronic configuration of element before D and after E. It actually means 2 elements. 1 element before D. So since D has 16 proton number, therefore one element before D, it has 15 proton number. So awak ikut je proton number 15, tuliskan dia punya electronic configuration. So dia akan sampai 3p3 saja. Okay, and then element after E means another element. So if E you have 30 proton number, therefore the element after E will have 31 proton number. Okay, so kalau madam tengok pada element after E. So 31 proton number give you the electronic configurations up until 4s2, 3d10, 4p1. Okay, kalau dia sudah masuk 4p, okay, now the last electron is inside P subshell. That means this element is inside P block. Okay, kalau untuk P block, so you have to look at here. The valence electron including 4s2 and 4p1. Sebab P block starting from group 30. That means you should have 3 valence electron. So if the electron entering the P subshell, then the 3D orbital, you move it inside. So it won't be confused for you to identify the valence electron. So 3D, 10, 4S2, 4P1. So jadi dekat sini adalah awak punya valence electron. Valence electronic configuration. So those who are making mistake for the part B and also part D, please do your corrections and correcting your concept. Tak payah reset. Cuma madam nampak ada beberapa orang yang salah dekat valence electron. That's very dangerous. Okay, so far any questions for question number 4 here?
No, madam.
Okay. So if no questions, we're looking at the atomic size. Most of it is the sentences. Okay, so madam will go through with you and you can highlight in your notes or you can jot down something important. Okay, so atomic size, atomic radius, it means the same thing, and you need to know the train across the period and also down the group. So let's look at across period. So this across the period, it always means that it moving from the left to the right. Dari kiri ke kanan. Okay, and then across a period, number of proton increases or the nuclear charge increases. And the effective nuclear charge will increases as well. So imagine the proton number increases, but the inertia remains the same. Okay, like just now, right, the oxygen and the fluorine. So you can see positive 6, positive 7, it keep on increasing when the proton number increase. Okay, so since the effective nuclear charge increases, the attractions between nucleus and the outer electron increases as well. Sebab dia punya daya tarikan dia sudah meningkat. Jadi attraction dia pun jadi makin kuat. Okay, so when your attraction is getting stronger and stronger, therefore nucleus are able to pull inside your outer electron. So when the outer electron is pulled closer to the nucleus, therefore the atomic size or atomic radii will become smaller, will decrease. So from the across the period from left to right, you will see the atomic size getting smaller and smaller. Contoh daripada group 1 kita ada sodium. Sampailah argon, dia akan jadi makin kecil. Okay, so atomic size will decreases. So if you're looking at the example given you the sodium and the magnesium, proton number 11 and 12. So in the table, it's something similar like the diagram just now. Proton number 11, proton number 12, but the inner electrons are the same. Okay, so if you're looking at 1s2, 2s2, 3p, 2p, 6, 3s1. Okay, so core electron, you have 10 electron. Inner electron, you have 10. Magnesium also the same thing. 1s2, 2s2, 2p6, 3s2. The inner electron also you have 10. Therefore, when your proton number increases, okay, the effective nuclear charge also increases. So since magnesium has higher effective nuclear charge and experience stronger nucleus attraction, therefore the magnesium will be smaller. Now, because the attraction is getting smaller, therefore magnesium, it will be smaller. So in short, we can say that across a period, atomic size decreases. But the main point over here, you need to understand and need to remember which factor affecting the size. Across a period, we are using proton number. Okay, proton number and also your Z effective. So any questions for the train across a period?
Madam,
Yeah.
Saya tak faham sangat yang attraction between nucleus and outer electron increase.
Okay, tak faham dekat nucleus attraction ya. Tapi untuk proton number dengan Z effective boleh faham ke?
Faham.
Ya, itu faham Okay, so sekarang kalau madam imagine lah. Sorry. Over here, if let's say the effective nuclear charge madam pakai sebagai satu magnet. Magnet ini dia simbolik positive 1. So now for sodium, positive 1, the Z effective. And then for my magnesium, I have a stronger magnet over here, positive 2. Okay. And then the nucleus attractions, it focus on the outer electron. So that means how much stronger I can attract the outer electron. So let's say over here, the valence electrons for imagine this magnet is my nucleus. Okay, and then I have my orbit or the energy level around here. So if let's say this is my electron. So over here, this means the forces of attractions between nucleus and the electron. So now if I have a stronger magnet, do you think it will attract stronger or weaker? Stronger. So dekat sini, madam pakai dua arrow dekat sini. Maksudnya dia punya attraction. Kalau magnet bertambah kuat, attraction dia akan jadi makin kuat. So dekat sini samalah. Higher effective nuclear charge macam awak punya magnet. So nucleus attraction dia akan jadi makin kuat. So bila dia jadi kuat, okay, attraction dia jadi kuat. So this energy level, it will kind of pulling inside. Dia akan tarik dia masuk sampai dekat dengan nucleus. So imagine kalau dia tarik masuk, jadi dia punya size akan mengecut. Dia akan jadi kecil. So in this case, you need to remember what is the relationship between the effective nuclear charge and the nucleus attraction. Cuba imagine lah, dia kena tarik masuk. That is the attraction. Is that okay for you?
Okey, tapi dia tak ada kaitan dengan Zef
Yeah.
Z
Kalau across a period lah, kita tengok pada Z dengan Zef. Okay?
Okay.
Alright. So next one, we move into the train down the group. So of course, down the group from the top to the bottom. So we say that when we're going down the group, any of the group, it can be group 1, group 2, group 17, 16, whatever group. So down the group, number of shell increases. Okay, so if you're looking at the diagrams over here, this one obviously is our lithium. Okay, with 3 proton number. And then this one is our sodium with 11 proton number. Okay, so if you remember, or those who know how periodic look like, group 1, we starting from hydrogen, then we have lithium, sodium, potassium. This is the 4 main element in our group 1. Okay, so for lithium and sodium, down the group, number of shell increases. So number of cell represented by a symbol N. So when this shell increases, again, shell related to screening or shielding effect. So we will talk about shielding effect. Tadi across period Madam cakap Z dengan Z dia sekali kan. So bila awak mention shell, awak kena mention juga untuk shielding effect. So ini adalah satu pair. N dengan shielding effect satu pair. Okay, so when the number of shell increases, the shielding effect increases. Therefore, the distance between the nucleus, okay, and your outer electron increases. So this one is just common sense. You adding the number of shell, shielding effect increases. Therefore, the distance between nucleus and the outer electron decreases. So if you can see over here, the distance increases. So the attractions between nucleus and your outer electrons will decrease. Kenapa decrease? Sebab dia makin jauh. Bila jauh, awak imagine magnet dengan satu paku. Kalau awak letak jauh, dia punya attraction sudah kurang dah. Makin jauh, makin kurang. Okay, so that is a common sense. This distance increases, the forces of attractions will reduce. Therefore, going down the group, the atomic size will increase. Okay, so we're looking at the example lithium and also sodium. Sodium has more inner electron. Okay, and experience a stronger shielding effect. In this case, Madam nak awak tambah lagi satu ayat ya, has more inner electron and more number of shell. Therefore, it experience stronger shielding effect. Yang paling penting adalah number shell dengan shielding effect. Sebab dia punya bilangan elektron bertambah. Okay, sebab tu kita kena masukkan dalam shell yang lagi satu. Okay, more number of shell, stronger shielding effect. Therefore, the attractions between nucleus and the outer electron in sodium is weaker. Okay, therefore, sodium has a bigger size than the lithium. Or we can say the atomic radii of sodium is bigger than lithium. And then in short, we can say going down the group from hydrogen, lithium, sodium, potassium, the size are getting bigger and bigger because you are adding more and more energy level and the shielding effect. So is anyone having questions about the atomic size going down a group? Ada soalan ke? Okay, enough questions, then we continue, yeah? Okay, so here is a diagram to look over here. This is our group 13, 14, 15, 16, 17, and 18. Okay, we are only looking group 1, group 2, group 13 until group 18. Okay, your S block and also P block only. when we're talking about the general trend across a period or down the group. So if you look over here, atomic size across a period, from left to right, the atomic size decreases from lithium until neon, from sodium to argon, potassium to chromium, krypton, and so on. But when you're going down the group, okay, going down a group, any of the group you can see, going down group 1, hydrogen until rubidium, cesium, the atomic size increases. Going down group 17, fluorine until iodine, the size increases. So this is the general trend that you need to understand. So if the questions ask, in the periodic table, which element is the biggest? Lithium. In periodic table, which element is the smallest? Helium. Very easy. Okay. So any questions for this part? So remember atomic size or atomic radii, we're talking about 3 categories. Okay. Across a period, down the group, and one more is the size for transitions element. We separate into the general trend inside this picture. Okay, sebab size untuk transition element dia lain. Okay, so let's look at this one. Atomic size or atomic radii of the first row of transitions element. We are only talking for the first row. Yang lain kita tak ceritakan kita hanya fokus pada period 4, row pertama untuk transition element sahaja. Okay, so for transitions element, the atomic size will decrease as first. So memang daripada kiri ke kanan, size dia akan decrease dulu. So for transitions element, it only starting, it will decrease. But then it will remain fairly constant. So bila awak nak ceritakan size untuk transition element, awak mesti ceritakan dua part. Decrease at first and then remain fairly constant. That means all the element inside block D, okay, transition element, the size almost the same. Okay, almost the same. That is because if you know that proton number in the periodic table is arranged increasing order. So obviously inside the transition element also the same. You keep on adding the electron into the D subshell, adding into D subshell, adding into D subshell. So dia bila proton number sebenarnya bertambah. So just now we said that across a period when the proton number increase, Z effective will increase. Untuk transition element pun sama juga. Z dengan Z effective increases. Dan sepatutnya bila Z effective increases, size akan menjadi kecil. But that's not the case. It's because of this reason. The D electron fill the inner orbital, n equals to 3. Okay, so they show the outer electron, n equals to 4, much more effectively. So I'm going to show you one example over here. Let's say this is our nucleus. And then for transition element, we have 4 shells. Okay, looking at this last shell, if you look at 1s2, 2s, 2p, 3s, 3p, and then we're moving into 4s and 3d. So kalau awak ada tambahan elektron, kita memang dekat D subshell, adding. If you got 4 electrons, then we keep on adding into D subshell. So remember, madam told you before this by using a red pen and a black pen. Bila elektron masuk dekat D orbital, jadi energi dia akan kurang. Dan sepatutnya di 3D ni, dia adalah dekat n equals to 3. So when you are keep on adding the electron into the 3D orbital, you are actually adding electron inside the inner shell. Dekat sini memang akan ada banyak students akan tanya, madam, jadi kenapa kita kena masukkan 3D sebagai dia punya valence electron? Reason sangat simple, sebab D orbital belum penuh. So untuk valence electron kita akan ambil 4s dengan 3d. Kalau tak, valence electron awak ambil 4s2 saja, then setiap elemen dalam transition valence electron dia sama. So kita tak dapat nak bezakan. Okay. But the real thing, the real case is over here. So let's say over here for S2 we have 2 electron outermost. Yang ini adalah awak punya N sama dengan 4. Okay. The inner one over here N equals to 3. So if you remember about what you learned in your secondary school, you learned about 288 and then following. But actually the correct version is 2818. So that means N equals to 1 can fit into electron. N equals to 2 can fit in 8 electron. That means 2s2, 2p6. And then for your N equals to 3, your third energy level, you have 3s, 3p, 3d. So maximum number of electron, you can add in 18 electron. So any additional electron, we will add into the inner shell of N equals to 3. So dekat sini kita akan masukkan elektron dekat inner shell. So walaupun awak punya proton number increases, Z effective increases, but now the shielding effect also increases at the same time. Senang nak kata, effective nuclear charge increases, shielding effect increases. So dia akan cancel off dia punya effect. Okay, so kita tengok balik sekali dia punya ayat ya. Okay, the d electron fill the inner orbital N equals to 3. So they show the outer electron much more effectively. And in that case, the outer 4s electron are not pulled closer. Okay, and then the size will remain fairly constant for all the transitions element. Okay, and then we confirm one more time using this diagram. So you can see group 1, group 2, group 13, group 18, the size is getting smaller and smaller from left to right. But if you look at the transitions element, the size remains almost the same. That is the reason. Okay, increasing effective nuclear charge is cancelled off or is shielded by the inner d electron. Okay. Boleh tambah lagi satu ayat dekat sini lah. Kalau untuk ayat yang lagi simple, awak boleh catat dekat sini. Okay, I'm writing over here. You can jot down inside your notes as well. The increasing Z effective is shielded by the increasing shielding effect, increasing the electron. Increasing the inner electrons. So both increasing at the same time, so the effect is not very strong. So you will see the size remain fairly constant. So remember, we're only talking about the first row of the transitions element. So is any questions regarding to the atomic size for transition? Ada soalan dekat sini?
Tak ada.
Okay, kalau tak ada soalan, kita tengok soalan pertama, example questions. So over here, Madam have already pre-write for you the electronic configurations, just to let you know how to identify the trend. Okay, so if you look at the questions, explain the train. So when you look at the train, you are talking about increasing order, decreasing order, or the size remains fairly constant. Okay, so atomic radius for the following species. For A, you have beryllium, magnesium, calcium. So over here, giving you the proton number, you can list out the electronic configuration. Okay, so over here, beryllium, you have only 2 energy level. For magnesium, you have 3 energy level. For calcium, you have 4 energy level. So we can see what is your main factors affecting the size. What is the main factor? Anyone? What is the main factors that affecting your atomic radii for beryllium, magnesium, and calcium?
The number of shell is increasing.
The number of shell increasing. Thank you very much. And then one more thing, common things you can see is the number of valence electrons are the same. So that means they are from the same group. Okay, so the main factors over here is the number of shell. Dekat sini madam buat short notes. You can write, you can practice to write in sentence. So since the number of shell increases, okay, the shielding effect, remember there are one pair, satu pasangan. Bila awak cakap pasal shell, awak kena ceritakan shielding effect. Okay, number of shell increases. Okay, shielding effect increases. How about the nucleus attraction? Jadi stronger ke weaker?
Weaker.
Becomes weaker. When we talk about nucleus attraction, dia ceritakan untuk daya tarikan dengan outer electron. So become weaker sebab protection dia jadi makin kuat. Okay, so nuclear attractions become weaker. Then how about the size, the atomic size or atomic radii from beryllium to calcium? Increases or decreases?
Increases.
Increases. Because the shells is increases, the size will increase. Okay, so this one is the general idea of going down the group, down group 2. Okay, but how about for part B? We have aluminium, we have phosphorus, we have chlorine. So electronic configurations over here, madam have already written for you. Aluminium, 3 valence electron. Phosphorus, we have 5 valence electron. And then chlorine, we have 7 electrons. So what is the main factors that are affecting the size? Any idea?
Number of proton.
Number of proton, yes, very good. You can see over here 13, 15, 17. So the number of proton or the nuclear charge increases. Therefore, dia punya pasangan kita akan ceritakan pasal ZEF. Okay, so proton number increases. Effective nuclear charge increases. How about the nucleus attraction? Become stronger or weaker?
Stronger.
Become stronger. So when it becomes stronger, it will pull the electron towards the nucleus. Then what happens to the atomic size or the radii? Decreases. Okay, or becomes smaller. So this is the train across a period. Okay, similar like a train across a period from aluminium to chlorine. So this is period 3. So everyone is clear about this 3 category or atomic size. Kita ada 3 kategori transitions element, across a period dengan down the group. Is everyone alright? Any questions? Tak ada soalan Tak ada soalan, madam teruskan ya.
Tak ada.
Okay.
Ada.
Right. So if no questions, the next thing we want to look at is to compare between atomic size and the ionic size. Just now we are talking about atomic size. Now we further into ionic size. Okay, so ion is divided into cation, positively charged, or anion, negatively charged. So let's look at sodium first. Okay, our cation. So you have already know that to form a cation, we need to donate or we lose or remove 1 electron. So over here, electronic configurations for a neutral sodium is until 3s1. So in order to achieve the octet configuration, you need to lose 1 electron. You need to remove 1 electron to become octet. Okay, similar like a noble gas configurations to become Na positive. So now, by losing one electron, you can look at the table over here. Number of proton is the same because it's the same element. And then nuclear charge, all the same. Effective nuclear charge also the same. If you want to write down the nucleus, effective nuclear charge is +1, also the same. But the number of electron is different. Okay, so we are comparing about the differences. Benda yang sama kita tak dapat nak bezakan. So kita kena ceritakan untuk benda yang berbeza. So in this case, we need to talk about the differences for the number of electron. So looking at the explanations over here. When cations form, electron is removed from the outer shells of the parent atom. So remember, parent atom is neutral. Okay, therefore, the electron-electron repulsion decreases. Sebab elektron sudah berkurang, maka dia punya repulsion automatic dia akan berkurang. Okay, so when you talk about repulsion, we talk about electron cloud. So sebenarnya elektron dia macam satu kelompok awan. So this electron cloud, because the repulsion decreases, it will shrink. Okay, shrink maksudnya mengecut. It will shrink. So when the electron cloud shrink, the attractions between the nucleus and your remaining electron become stronger. Sebab dia sudah mengecut kan. So jadi semua elektron yang ada, tiba-tiba hilang. Okay, so semua elektron yang ada dia jadi makin dekat. Okay, antara satu sama lain. Therefore the attractions will become stronger. And then the size of your cation will become smaller. Okay, so here is a few points that you need to remember. Remember about talking about repulsion, talking about electron cloud, and of course link to the attractions, and then it will bring you to the conclusions of the size. So attractions become stronger, size becomes smaller. So size of a cation, Na positive, is smaller than Na, the neutral parent atom. So we can do a general idea that a cation is smaller than the neutral parent atom. Untuk semula kalau kita compare dengan Na2 plus dengan compare antara magnesium 2 plus with magnesium, compare between potassium positive with potassium, all is the same. Cation is always smaller than the neutral parent atom. Okay, so that is about the cation. And we have also a negatively charged ion, which we call as the anion. Okay, so we taking the example for fluorine, proton number 9, electron configurations 1s2, 2s2, 2p5. That is for neutral fluorine. So in order to achieve the octet configuration, you need to accept, okay, one electron. So the extra one electron will put into the 2p subshell. Belum penuh lagi, so kita penuhkan dia jadi 2p6. Okay, so now you are adding electron inside your electron cloud. So let's look at the definition. Again, the same thing like inside the table is for you to see what to compare. Okay, we are comparing the differences, yeah? So comparing the number of electron. The anion having an extra electron. So the explanations over here, when an anion forms, electron is added to the outer shell of parent atom. Therefore, the repulsions between electron increases and the electron cloud will expand. Tadi awak keluarkan dia mengecut. Sekarang awak tambah electron cloud dia akan expand. Mengembang. So the attraction over here becomes weaker because your electron cloud explain repulsions greater. Therefore, attractions will be an opposite way. It will become weaker. So the size, since the attractions become weaker, the size will increase. Okay, the size of the negatively charged ion will become bigger than the neutral parent atom. So we can also comparing in this way according to the example fluorine. So F minus, the anion, is bigger than the parent atom fluorine. Or generally, we can say that anion is always greater than the neutral parent atom. Okay, dia berbanding dengan atom dia sendiri sahaja. Cl compare dengan Cl minus. S compare dengan S2 minus. O compare dengan O2 minus. So dia compare dengan dia punya parent sendiri. Okay, so that is the comparisons between the atomic size and the ionic size. So is there any questions in this page? So untuk chapter ni memang banyak explanation banyak explanation, banyak essay. And then this one will be come out in your assignment questions. So any questions for this one?
Tak ada.
No, madam.
Juga ya, okay. So let's look at these questions. Write the electronic configurations for each species below. Typing error. Compare the size of the following pair. So kalau madam tak tulis, boleh ke awak bagi tahu madam mana satu species dia lagi kecil? Kalau untuk A, AL ke AL3 positif? Mana satu lagi kecil? Which one is smaller in size?
PL.
L plus.
AL3 plus or AL?
G plus.
AL3 positive. So just now we said cation is always smaller than the neutral atom. So let's say madam do it this way. Okay, and then anion is always bigger than the neutral parent atom. Okay, if you still not confident, then we look at the electronic configuration. So let's say aluminium 1s2, 2s2, 2p6, then we have 3s2 and 3p1. So when you are forming so this one is for Al, and then when you are forming Al positive 3, you are removing away your valence electron. So become like this. So obviously you can see the electron repulsion decrease or increase? Decreases. So if you want to do comparison, electron repulsion, madam guna short form. Okay, for Al3 plus is smaller than the parent atom. Okay, because now it has less electrons, so repulsions will be smaller. And then the electron cloud of Al3 plus also smaller or is string comparing to your parent atom. So how about the attraction? How about the nucleus attractions?
Become stronger.
Stronger or weaker?
Stronger.
Okay, therefore the size, which one is smaller? Ionic size of Al3 plus, because attraction stronger, ionic size will be smaller than the original neutral parent atom. Okay, so for sulfur, which one is smaller? Is it S or S2 minus? 2 negative.
S.
S only. So if you're looking at the electronic configurations, why they are giving you the proton number is actually to ask you to write out the electronic configuration. Okay, so in order to form 2s negative, how many electron is added? 2. Added to where?
2.
To our p orbital, isn't it? Okay, so now the electron repulsion for our S2 negative is bigger than S or smaller than S? Electron repulsions between S2 minus and S, is it smaller or bigger?
Bigger.
Bigger. Okay, so we can do comparison in this way lah. We're using bigger than or smaller than symbol. Okay, so the electron cloud for our S2 minus, because repulsion is bigger, therefore the cloud will expand or become bigger compared to your parent atom. So the nucleus attraction, okay, for our S2 negative, smaller or bigger? Stronger or weaker?
Weaker.
Weaker than sulfur parent. Therefore, the ionic size of our S2 negative become bigger than our sulfur. Okay, and then we can say sulfur has a smaller size. Dekat sini awak boleh terbalik, tak ada masalah. Awak boleh ceritakan sulfur. Tapi yang lagi senang kita tengok mana satu yang berbeza daripada original. So we talking about that one. Okay, so this is the way of you explaining the train. Okay, explaining the comparison. So since the question asks you to compare, therefore you need to explain. Ataupun kalau soalan minta awak deduce, perkataan deduce sendiri, selain bagi jawapan, awak kena buat explanation. Ataupun soalan minta rationalize, awak pun kena ceritakan sikit. Okay. So let's look at the exercises. Because it's fill in the blank, then we discuss it together. All right. So for the question number 1 here, we can see sodium, magnesium, aluminium, sulfur, chlorine, the sizes decreases. So based on the diagram above, is the element in period 3. Briefly explain the variations in atomic radii from sodium to chlorine. So variation also the train. Ada masa dia minta train, ada masa dia minta variation. So sodium, magnesium, aluminium, sulfur, chlorine are in which period? Ini soalan sudah bagi ya. Isi sama-sama. Naik. In the what period?
Period 3.
In the same period, period number 3. Questions is already given. Okay. Across a period from sodium to chlorine, number of proton
Increase.
increases. Okay, then what is increases as well?
Zef.
ZEF, okay, or your effective nuclear charge. Boleh guna simbol boleh guna Z ataupun ZEF. Nak tulis penuh pun boleh. Kalau awak takut awak lupa ZEF itu ialah apa, awak tulis effective nuclear charge. So nucleus attractions towards outer electron. Attraction macam mana? So biasanya attraction method akan guna perkataan stronger or weaker. So become stronger or weaker? Stronger because you increase the ZEF. Therefore, outer electron pull closer and the size of atom decreases. Okay, decreases from sodium to chlorine. Okay, kalau soalan sudah bagi awak elemen jangan mention general. Awak mesti kena specify. Dari mana ke mana. Mesti kena ada. Unless dia suruh macam general. Explain the train across a period. Dia tak ada bagi awak elemen, tak ada bagi period. Tak ada masalah awak explain secara general. Tapi kalau soalan macam ni, dia sudah bagi sodium sampai chlorine kan. Okay, dalam awak punya explanation, awak cuma tambah from where to where. From sodium to chlorine. From sodium to chlorine. Tambah perkataan ini saja. Dia sudah jadi spesifik dah. So this one you need to write out. From where to where, this is important. To explain according to the answer. Okay. So jot down your answer. So later for the completed exercises, we discuss over here, heading into the Google Classroom. So maksudnya kita sudah explain, madam sudah explain, dah bagi jawapan, awak hantar dekat situ sebagai record sahaja. Okay, sebagai madam punya record. Alright, question number 2. Table 1 shows the atomic radii of element in group 17. So fluorine, chlorine, bromine, iodine. So we know this something to do with down the group. Okay, so discuss the trend of atomic radii for the above element. So fluorine, chlorine, bromine, iodines are in the same group. Which group?
17.
Group 17. Well done. Okay, so atomic size increases or decreases? The numbers, the values of radii is given.
Increases.
Increases from fluorine to iodine. Nak tulis macam ni boleh, nak tulis dalam ayat from F to I pun boleh. So this show that fluorine is at the of the group and I is at the of the group. Nak isi apa? Group 17, fluorine, chlorine, bromine, iodine. At the top of the group. And iodine is at the bottom of the group. Satu kat atas, satu kat bawah. Of course kat bawah ada lagi. Cuma kita ikut soalan dia sampai iodine saja. So kita cerita untuk soalan ni saja. Okay, so fluorine at the top of the group, iodine at the bottom of the group. And down the group, what is increases?
Number of shell.
Number of shell. So, what is increase as well? Ingat satu pasangan?
Shielding effect.
Shielding effect. Ingat kalau ceritakan pasal Z, dia akan ikut dengan ZEF. Kalau ceritakan number of shell, kita akan ceritakan, nak tulis shell pula. Okay, kita akan ceritakan shielding effect. Satu pasangan. Okay, Z dengan ZEF, N dengan shielding effect. So when N increases, shielding effect increases as well. So nucleus attractions become weaker or stronger?
Weaker.
Any idea? Become weaker. So outer electrons are further from the nucleus and therefore the size increase or decrease?
Increases.
Increases. Ini ialah kita punya introduction. Ini adalah kita punya summary. Conclusion. Dia macam satu short essay tapi kita boleh buat dalam point. Okay, maksudnya satu ayat satu point lah. Okay. So jot down your answer. Okay, question number 3. Select the atom or ion in each pair that has the largest radius. Cl or Cl minus, which one having largest radius? Which one having largest size? Radius is similar meaning Cl?
Cl minus. Cl minus.
Cl minus. Ca or Ca2 positive, which one is larger?
Ca.
Ca, well done. Nak practice ceritakan pun boleh. Tapi dekat sini Madam bulatkan jawapan saja. Okay, for 3B, indicate which of the following of the two species has the smallest size? Li or Li positive?
Li positive.
Li positive.
S or S2 minus? Bulat salah pula. Smaller size, we have Li positive. S or S2 minus, which one is smaller?
S.
Okay. And the last questions we have over here. Size of potassium is larger than K, while size of Br is smaller than Br minus. Explain. So explanation Madam pun sudah bagi. Boleh ke isi sendiri?
Boleh.
So Wabinya kerja nanti semua sekaligus hantar dalam Google Classroom. So soalan 1, 2, 3 Madam dah explain. Awak hanya perlu completekan soalan yang keempat. So question 1, 2, 4 handing into Google Classroom. So very simple, easy work ya. Okay. So the next thing Madam want to do is isoelectronic. So yang ini ada dalam video yang Madam suruh awak tengok semalam. Maybe some of you haven't watched it. You can watch it afterwards lah, but it will be slightly easier for those who have watched already. Okay. But first of all, anyone want to tell me what it means by iso? You learned about bio, right? What it means by iso? Same. Okay, iso, it has the meaning same. Electronic, you learn about electronic configurations. That means this species, when we talk about isoelectronic species, they must have same electronic configuration. So when you have same electronic configurations, of course, the number of electrons also the same. So either same number of electrons or same electronic configurations, both refer to isoelectronic. So a general trend over here within your isoelectronic species, now the number of electrons are the same, then we cannot compare electron. Tadi kita compare ion dengan atom kan. So kita compare number of electrons sebab yang itu berbeza. Tapi bila dekat isoelectronic species, now number electron become the same. Then we cannot compare anymore. Benda yang sama kita tak boleh nak compare. Okay, so within this isoelectronic species, we have to compare something that are different, which is the nuclear charge and the ZEF. So in general, we say that within the isoelectronic species, the higher the nuclear charge, okay, the higher is your ZEF. Therefore, you will have a stronger nucleus attractions and you will have a smaller species. Dia macam awak punya trend across the period. Cuma sekarang kita tukar subject. Subject tukar kepada isoelectronic. Okay. So untuk dua example dekat sini pun ada dekat video. So Madam just touch and go only. So if you're looking at the table over here, given you sodium positive, magnesium 2 positive, Al3 positive, and silicon 4 positive. So all the number of electrons are the same. We cannot compare. Then the only choice for us to compare is the Z, okay, number of proton. So all of these 4 species are isoelectronic. They have same number of electron of 10, same electronic configuration, 1s2, 2s2, 2p6. Therefore, we're comparing the proton number. So when proton number increases, effective nuclear charge increases from sodium positive to silicon 4 positive. Okay, so over here is a 4 positive. So the attractions between nucleus and the remaining electron become stronger. Therefore, the ionic radii or the ionic size decreases from sodium to silicon. Ataupun kalau soalan hanya bagi awak sodium dengan magnesium ataupun magnesium dengan silikon, awak boleh bandingkan. Okay, silikon lagi kecil daripada magnesium contohnya. Sebab kita bandingkan dia punya proton number. So the trend over here, sodium positive is the biggest, and then silicon 4 positive is the smallest among these 4 species. So is that all right for the first example for sodium positive until silicon 4 positive? Any questions? Ada soalan nak tanya? Any questions? No questions? Ada soalan ya?
Tak ada. No.
No, madam.
Yeah. So the next one, example phosphorus. We change, just now it's all cation, now it's all anion. We have phosphorus 3 negative, sulfur 2 negative, and then chlorine 1 negative. So number of electrons all are the same. Then we compare the proton number, your Z, and also the Z effective. So all of these are isoelectronic species. with 18 electrons. Okay, so the electronic configurations is according until 3p6. So when proton number increases, so we arrange accordingly lah, P3 negative, S2 negative, and then Cl negative 1. So proton number increases, if you look at this table over here, 15, 16, 17. So proton number increases from P3 minus to Cl minus, effective nuclear charge increases. Therefore, the attractions between nucleus and the remaining electron become stronger. So Z effective increase, attractions become stronger, and the ionic radii decrease. So if you're comparing between phosphorus and the chlorine, phosphorus, it will be much more bigger. Alright, and then chlorine would be smaller because it has a bigger Z and Z effective. So dekat sini awak kena ingat, kalau Z ataupun Z effective dia tinggi, dia besar, maka size dia kecil. Dia macam inversely proportional. Bigger the Z or Z effective, smaller the size. Or the other way around. Smaller the proton number or the Z, okay, bigger the size. So now, let's look at the questions example here. Identify the species that are isoelectronic and then comparing the size. So which of these ABC are isoelectronic? Tengok macam mana? Any idea how are we going to look at the isoelectronic species? Ada cadangan? B. B dengan siapa?
A.
A. So how are you going to look at the isoelectronic species?
Number of proton.
Number of proton, kita keluarkan electronic configuration dia. Ataupun awak boleh tengok, okay, 20 proton number ataupun 20 elektron. Kita keluarkan 2 elektron, dia jadi 18. So from here, you need to write out if you want to, or you can also straight away finding the number of electrons. So in this case, okay, 3p6, if the neutral calcium, we have up until 4s2, but now you are removing, so we have up until 3p6 only. And then K positive, 1s2, 2s2, 2p6, 3s2, 3p6. And then if you following the proton number, you will up until 4s1. But because positive charge, removing one of the valence electron, it up until 3p6 only. Then for oxygen, we up until 2p6 only. Okay, because originally until 2p4, after adding 2 more electrons, become 2p6. So calcium 2 positive and potassium positive is your isoelectronic species. So which one is bigger in size? Any idea?
B.
B is bigger in size. What is your reason?
Proton number dia sikit.
Proton number dia sikit. Tadi madam ada bagi kan, the bigger the proton number, the smaller the size. Okay, so if let's say you want to compare, you can write down also. Okay, this is the proton number. ZM bukan 2 Okay, number of electron is the same. Number electron is 18. Both are the same. Then we cannot compare electron. We have to compare the proton number. Okay, bigger the proton number, bigger the ZEF. The bigger the ZEF, the stronger the attraction. Okay, the stronger is the attractions between nucleus and remaining electron. Therefore, Ca2 positive has a smaller size. Okay, please get your idea, and then after you get your idea, you can practice writing into sentence. The main thing is to get the idea first. How to do comparison, what factors to use, what explanations to write. So in this case, calcium 2 positive with the higher proton number and the effective nuclear charge has the smaller size. All right, you can jot down for the answer for the example questions 1. Isoelectronic is quite a popular questions in every year past year questions. Okay. But then you will not be tested in the exam, then it surely will come out in your assignment. So next part about isoelectronic as well is looking at the train. So just now we compared, now we want to talk about the train. Okay, explanation is quite long, so madam will go through, but the explanation is quite similar to just now. So looking at the train in ionic size across a period, you will see the general trend here. Ionic size decreases across a period. Now we are talking the ionic size. Ionic size when you form the Na positive, Mg2 positive. Okay, but it will increase significantly from cation to anion. So we know that anion is bigger because more electron, anion, cation is smaller because less electron. Okay, so if you're looking at this as this diagram, okay, you can see the trend going down. Going across a period for sodium to silicon, the ionic size decreases. Okay, but until silicon, there is a great difference between silicon 4 positive with phosphorus 3 negative. So what happens over here? We need to explain. Okay, and then after that, again, a similar trend decreasing. Okay, ionic size decreasing. Then we have to talk again about the ionic species. So look at the explanation, similar like just now. Cuma cara presentation dia lain. Tadi kita separate kan? Sekarang kita gabungkan sekali untuk semua elemen dalam period 3. Okay, so sodium to silicon, isoelectronic, same like just now. Proton number increases, effective nuclear charge increases. Attractions become stronger, ionic size decreases. That is to describe the first train over here. All right. And then after that, we have our second part explanation is comparing between silicon 4 positive, okay, and the phosphorus 3 negative. So now there is a great difference in the number of electrons involved. So we are not looking at the Z and the Z. We're looking at the differences of the electron. Okay, so there is a great jump of the ionic size from Si4 positive, 10 electron, to phosphorus 3 negative, 18 electron, because there is 3 electron added to the 3p orbital in p3 negative. Okay, if you don't want to mention about 3p, no problem. You just mention there's extra 3 electron in p3 negative. Pun boleh. Okay, then we are comparing about the number of shell. So if you're looking at the silicon, 10 electron, we only have 2 shell. Phosphorus 3 negative yang ini ialah silicon for positive. Phosphorus 3 negative, okay, we have 1, 2, 3 in order to accommodate your 18 electron. Okay, therefore over here, principal quantum number or your energy shell increases. Electron repulsion increases, or you want to talk about the shielding effect because you mentioned about the N. Okay, so over here we can add along the shielding effect. But the important thing is now we are comparing about number of electron. So number of electron linked to repulsion, linked to electron cloud. Okay, refer kepada table tadi yang kita cakap pasal anion. Okay, so electron repulsion increases, electron cloud expand, therefore the attractions becomes weaker. And you have a sharply increase in size for the phosphorus 3 negative. Okay, ionic size increases sharply from Si positive to P3 negative due to this repulsion. Okay, so the second explanation, second paragraph over here refer to the train in the diagram for the part 2. So any question up until here? Ada soalan tak? Ke semua orang dah tidur? Chapter 3 memang banyak explanation ya. Pastikan awak faham dan tahu macam mana nak how to say ya, nak explain ataupun nak ceritakan. Okay. Last sentence over here, the last train, we talk about phosphorus until chlorine, which is similar like just now. Isoelectronic, proton number increase, effective nuclear increase, attraction stronger, ionic size decrease. So this talking about part 3 inside the diagram from phosphorus into chlorine. This is part 3. So kalau keluar soalan macam ini dalam awak punya assignment, maka awak kena explain lah ketiga-tiga train. Tiga-tiga part. Part 1 decrease, part 2 sharply increase, part 3 decrease lagi. So kena ada 3 part untuk explainkan satu diagram dekat sini. Is there any questions before we move forward into the questions?
Ida,
Yeah.
kalau kita kata ada isoelectronic, kita kena tulis ke electronic configuration tu?
Ya, betul. Sama ada awak tuliskan electronic configuration ataupun awak keluarkan bilangan elektron. Both are fine. So if let's say over here I write 10 electron, also can. Over here I write 18 electrons. Can, no problem. Sebab dia memberikan maksud yang sama. Okay. So let's look at the exercises. Okay, for this one also mentioned in the video, so madam put it as exercises for you to fill in. Okay, let's look at together. If you look at the isoelectronic species from period 2, the anion, and period 3, the cation, all of the species mentioned over here having 10 electrons with the electronic configuration 1s2, 2s2, 2p6, 10 electron. Okay, so you're looking at this one. Nitrogen, 3 negative. Okay, oxygen, 2 negative. Fluorine, F negative. Proceed to period 3, sodium, magnesium, aluminium, cation. So all of this anion, all of this cation. But even though they are from different period, but after adding electron or after removing electron, all of them having the same electronic configuration. So we can class them together to look at the differences, to compare, to explain about the train. So anyone want to tell me about proton number for nitrogen? Siapa ingat proton number untuk nitrogen berapa? Ada tak siapa ingat nitrogen proton number berapa?
14.
7.
14 itu adalah mass.
7.
Yes, thank you very much. 7. So this is a proton number. How about oxygen?
8.
Fluorine.
9.
Sodium.
Sodium 11.
11. Magnesium.
12.
Aluminium.
13.
13.
13. So since all of them having the same number of electrons, we cannot compare electron. Then we have to look at what is the differences that we can explain. And now very obvious, the proton number are different. Okay, from 7, 8, 9, Then in between, actually 10 electron over here, we have neon, but we are not comparing for neon. Then we have 11, 12, 30. Okay, so all over here, you can see a very obvious trend, which is the increasing in the proton number. To remember, proton number increase, effective nuclear charge increase, and it will link you to a smaller size. So now you see everything we explained for these 2 hours is actually mean the same thing: Z effective and shielding effect, electron repulsion. So basically, we are keep repeating the same thing with different questions. Okay, so now given the species over here, all of them are isoelectronic species. Remember, this is a very important keywords that you must mention for every questions like this. Isoelectronic species. Perkataan yang sangat penting. Kena highlight kan. Okay, with a 10 electron. Or you want to write that electronic configurations, can, no problem. So when increases, what is increases? What is the increases from nitrogens to aluminium?
Proton number.
Proton number, or the Z, and the ZAF increases. Remember, they are one pair. So the attractions between nucleus and the remaining electrons become
Stronger.
stronger. Therefore, thus the ionic size decreases. Okay, so from where to where? From where to where? Ionic size decreases from
And
Nitrogen to aluminium.
N3 minus to Al3 positive. So remember, to answer questions specifically, you have to mention about the element in the questions. All right, so let's just move into the exercises below. Where's the time now? 9:33. Okay, so in this case, S2 negative and K positive are isoelectronic. Questions already mentioned, so you don't have to mention in your answer. Okay, with the electronic configuration 1s2 until 3p6. Compare the differences in the ionic radii. How are we going to compare? How to compare? First thing, what are we going to compare? Sulfur berapa proton number? Kalau number electron kita sudah tahu, electronic configuration dia sama, number electron dia sama. So, apa yang kita nak compare? Macam mana awak nak tulis? Sulfur, anyone remember proton number?
16.
16.
16, very good. Potassium?
19.
19.
19. Madam, macam mana Madam ingat? That's why Madam cakap, elemen 1 hingga ke 20 awak hafal. Kalau hafal, okay. Senang saja awak nak buat electronic configuration, nak buat comparison. Sebab semua ini soalan takkan bagi. Okay. Kalau sebelum ni dalam exam, mereka akan refer kepada table. So you take times to refer, you see. So it will be very easy if you can remember the first 20. Bukan suruh awak hafal 1 periodic table, tak. Hafal 20 saja. Okay, so sulfur 16 proton number, potassium 19. Therefore, we want to comparing the size. You can make a table like this and then afterwards you can write into the sentences. Tapi untuk table macam ni hanya untuk rujukan, bukan jawapan. Okay, so over here we will say that Z effective of sulfur, okay, is smaller than the potassium. I hope everyone is you know how to use the symbol bigger than, smaller than. Okay, so since the Z and Z effective of sulfur is smaller, how about the nucleus attraction for sulfur and potassium? Which one is stronger? Which one is stronger?
Potassium.
Potassium. So which size is, how about the size?
Potassium smaller.
Potassium small.
Potassium is smaller. Okay, so you can make your own sentences. Z and Z effective of K plus is bigger than S2 negative. Nucleus attractions between the nucleus attractions towards the remaining electron in K plus is stronger. Therefore, K positive has a smaller size comparing to S2 negative. So practice writing your sentence. Ke nak madam bagi juga? Tak payah kan? Boleh kan? So any questions for part 1? No questions, huh? You tak ada soalan, madam memang gerak saja tau. Soalan nombor 2.
Okay.
Okay, question number 2. Silicon, sodium are element period 3. Electronic configuration are the same. But they already give you the comparing in size. Ionic radius of silicon is smaller. So you need to explain why. Okay. So over here, fill in the blank you follow lah. Either you want to explain about Na positive or you want to focus on Si 4 positive. You want to explain silicon or sodium, it's actually free to choose. But because madam is already given over here, then we explain over here. Okay, so Si4 positive and sodium positive are, what do you want to fill in the first column here?
Isoelectronic.
Thank you very much. Isoelectronic species. The proton number of is bigger than, so which one is bigger? Which proton number of species?
Silicon.
Silicon. Jangan tulis Si sebab soalan ini bagi Si 4 positif. Tulis Si 4 positif. Okay, bigger than Na positive. And then effective nuclear charge of silicon as well is bigger than sodium. How about the next one? Attractions towards the remaining electron in silicon 4 positive is?
Smaller.
Attraction is the force, right? So we use stronger or weaker. So which one?
Stronger.
Stronger. And therefore, ionic size of Si4 positive is?
Smaller.
Smaller. You repeat and make a conclusion according to the questions. Okay? So,
Teacher.
Yeah?
Yang proton number SI tu kita kena ambil yang 14 ke ataupun kita dah siap tolakkan dengan 4?
Oh, proton number dia tak ada tolak 4. Yang tolak 4 ialah nombor
tu elektron
Ya, betul. So proton number tak kisah dia untuk neutral parent atom ataupun ion, dia tetap sama. Kalau 14 untuk Si, 14 juga untuk Si positive form.
Okey, baik. Faham.
Alright. Good questions. So everyone take notes. Number of proton are the same for both atom and also ion. That's why we're comparing about proton. Okay? So jot down your answer. And then we move into dah siap ke soalan 2? If you are done, then we move to question number 3. I think this one is your last question. Okay. So question number 3. Wow, tengok dekat table macam menakut kan. Kalau madam tak bagi untuk list ini, awak kena explain sendiri tau. Semua ni awak kena explain sendiri. All this point is actually your answer. Okay, so we look at the table. The variations of ionic size for element across period 2 is shown in the table below. Okay, so we are giving lithium positive until fluorine negative. So if you can see over here in the radius column here, 0.060 until 0.136. So what happened?
Increasing.
Are you sure increasing?
Uh,
0. Okay,
macam
kejap ada highlight kan. Lithium 0.06, beryllium 0.03, 0.02, 0.015. Tiba-tiba sampai nitrogen dia jadi 0.1. Kemana hilang 0.0?
tahu.
Tak tahu. Apa beza antara C4 positif dengan N3 negatif?
Dia punya group.
Nah, nampak tak perbezaan dia kat sini? Daripada lithium Li positif until carbon 4 positive, the radius decreases. Then suddenly, until N3 negative, it increased sharply. This one increased a lot. And then it decreased again. So this is similar like our diagram just now. Dia sama macam tadi yang trend dekat sini. Trend dekat period 3. Turun, naik, turun. Exercise ini pun sama. Turun, naik, turun. Cuma satu dia bagi graph. Satu lagi dia bagi dalam table. So please pay attention to the value given in table. Okay. So we look at the first part over here. Part yang pertama kita ceritakan daripada lithium sampai carbon 4 positif. Okay, so looking at this one, are isoelectronic species with electronic configurations of 1s2. So from Li positive, beryllium 2 positive, boron 3 positive, and carbon 4 positive are isoelectronic species. Okay, and then you continue. When proton number?
Number.
Increases.
Increase. Proton number untuk lithium 3, beryllium 4, boron 5, carbon 6. Nanti dekat nitrogen 7, 8, 9. Ni proton number dia. Okay, so when proton number increases from lithium positive to carbon 4 positive, how about effective nuclear charge?
Increases.
Increases as well. So what happens to the attraction? It becomes
Stronger.
stronger. Therefore, you were having the ionic radius decreases from Li positive to carbon 4 positive. Either you write this way, or you can write out the ionic radii decreases from Li to carbon. So either one. So this one is explaining the first part, yeah, from our lithium positive until carbon 4 positive. Okay, and then the part 2, we're explaining the differences between C positive 4, okay, with our nitrogen, the cation and the anion. Why is it so different? So we will want to see the number of electrons. There will be a great jump in size from which one having 2 electrons? Jangan tanya madam kenapa dapat 2 elektron, awak keluarkan electronic configuration. Lepas tu keluarkan 4 elektron, awak akan nampak. Semua ni ada 2 elektron. Bilangan elektron ini tengok pada proton number, tolak kan dia punya elektron yang awak kena remove. So over here we have the carbon 4 positive. And then 2 nitrogen, 3 negative. So over here you can see a very sharp difference, okay, between the carbon and the nitrogens in terms of the number of electrons. Okay, so electrons are added to orbitals to form N3 negative. So masuk dekat orbital yang mana satu? Ataupun awak boleh mention lah, electrons are added to the outer shells to form N3 minus. So this one is not the keywords. The orbital is not the keywords. You can mention outer shell as well. So dekat sini kalau awak tahu proton number untuk nitrogen 1s2, 2s2, 2p3. So the electron is added to the 2p orbital. Okay, so electron is added towards here to become N3 negative. So there is increase in the tambah dekat apa? Increase in what? Hello, students.
Principal quantum number.
Principal quantum number. Okay, accepted. Principal quantum number. Or we can say increase in the number of electron. Nampak? Dia punya electron bertambah. Okay, so increase in the number of electrons. From the original 7 electron, we added 3 electrons to become 10 electrons. So increase in the number of electrons. Okay. So what happened? The next sentence, the field inner electron has effectively shielded the outer electrons from the nucleus attraction. Yang ini, kita bagi pilihan Field inner electron, is it partially filled, halfly filled, or completely filled? Yang ni ayat tambahan daripada tadi lah. Yang tadi tak ada benda ni Cuma nak bagi tahu the forces at attractions is decreases. So what is it? What do you need to fill over here? Partially fill, completely fill, halfly fill.
Completely.
Completely, because you have already add in electron inside your 2p. So now 2s2, 2p6 is completely filled. Therefore, your electron repulsion increase or decrease?
Increases.
Increases. And the nucleus electron attractions become weaker. So the size increases sharply. From where to where? From which species to which species?
C4 plus.
C4 plus to N3 minus. Okay, so that explaining between C4 positive to N3 negative. So the next one, we are explaining from N3 negative, okay, to your F minus. So we can write over here N3 negative, and then over here we have what? O negative, 2, and then F negative 1, isoelectronic species. So now you have 10 electrons, or the electronic configuration, 1s2, 2s2, 2p6. So again, the same thing, fill in the blank. We have proton number increases, Z effective increases, attractions become
Stronger.
Therefore, the ionic radii decreases from N3 negative to F negative. Is everyone okay?
Okay.
Okay. So we have already complete for isoelectronics part. Right, so let's look at what we have covered today. So in the first part just now, we talked about the atomic size and also the comparing the ionic size between the ion and its parent. So you must, at the end of now, I hope everyone have already understand all this term and how to explain the train. So I think most of you is quite familiar. Ke Madam short sendiri saja. Untuk Z, our punya proton number or the effective nuclear charge, you need to also
Madam,
understand. Yes.
boleh tunjuk tak tadi slide sebelum ni tadi?
Okay. This one.
Alright. Got it. Okay, thank you.
Okay. So for the proton number or the nuclear charge Z, and then Z effective nuclear charge, you need to also understand the term shielding or screening effect. And then to conclude about the train, we have three categories. One of it is across period, your atomic size or atomic radius will decrease because of the increasing Z and Z. And then atomic size going down the group increases because number of shell and the shielding effect increases. So please also link back to the factors. And then after that, we have also talked about the train in transitions element. So element atomic size for transition element, only the first row period 4 will decrease initially and then afterward remains fairly constant because the effective nuclear charge and the shielding effect increasing at the same time. So they cancel off. Kind of cancel off lah. Cuma, macam tak sangat ketara dia punya effect. Okay. So the reason you can go back to the page which mentioned about the d inner electron shield the outer electron more effectively. And then we have compare about the ionic size. Size of cation is always smaller than its parent. Size of anion is always bigger than the parent atom. Then for the isoelectronic part, you need to understand about the definitions for isoelectronic. So that is the species with the same number. It doesn't matter atom or ion. Atom can, ion also can. So as long as they have the same number of electron or same electronic species. Ingat yang species dekat sini refer kepada atom ataupun ion. Dua-dua boleh. Okay. And then for isoelectronic species, focus on the Z and the ZEF. So if your Z and ZEF increases, nucleus attractions increases, becomes stronger. Therefore, the size for this species, okay, will have the smaller size. Unless they are not the same isoelectronic species. Macam tadi, example tadi kan, C4 positive with N3 minus, kita bandingkan electron. So when you're talking about electron, talk about electron repulsion, talk about the electron cloud, and then how it affects your nucleus attraction. Okay. So any questions until this part? We have already finished. So hantar sajalah untuk yang ni pun hantar dekat Google Classroom. Yang awak exercise dekat sini. Madam pun sudah discusskan untuk 2 part lah. You see. Okay. So untuk part yang tadi, soalan 1 hingga 4. 4 ni Madam nak suruh awak isi sendiri. Okay. Untuk exercise yang kedua ni pun sama. Hantar dalam PDF file dalam GC. Is that okay?
Okay, Madam.
Alright. So itu sajalah. Sekarang dah 9.54, dah tak cukup masa. So untuk quizzy hari ni Madam tak buat lah. Okay. So any questions before we end our session?